Welcome to Engineering Scale Models. I'm Jason, your host, and I do models and electronics, apparently. What's up with that? Let's check it out. We're talking about LCR meters here. I have two types here. I have my newer, more fantastic auto-ranging portable LCR tweezer meters here that we're gonna check out, and then I have my older Proster um, non-auto ranging LCR meter, and it has this feature where you can adjust the display up or down, whatever works for you. So we turn it on. How does that look? That looks pretty good, actually. So right now I'm at the 200 ohm range. So yeah, and I have two types of leads. I have the tweezer leads. So we're going to start with the tweezer leads on this one. And this will show you why I switched to an auto ranging one. Just because this is a little bit troublesome to mess with when you're doing troubleshooting stuff. So we're going to plug this into here, and then we're going to touch the two probes together, and then we're going to zero it out. Okay, let's check it again. Okay, well, that's how I did it before. Okay, well, we're not going to worry about the zeroing it out, apparently. So, what is this good for? So, let's take a circuit board here. And, you can measure things in the circuit here, like capacitors. So, I'm going to go to the 200 microfarad range, because just because we're gonna do this, and then I'm gonna come over here and I'm gonna grab this cap right here, and then we're gonna touch our probes to it, and it's saying 77 microfarad, 77.1 microfarad. Now that was measured in circuit, but what if that was reading a short? Well, we could come over here and we could see what the series resistance of that meter is, of that same capacitor. And that didn't range in. See, this is why I like auto ranging. Yeah, see, 0.85. Go down to 200 ohms. And we get about 72 ohms of resistance on that capacitor. So, and let's go to this one back here for an example, and let's see what this one is. So this one is got a 65 ohms of resistance across it. And then you can also measure inductors. Let's go to microhenries. And let's measure one of these inductors down here. Maybe we can do it with these. These are measuring zero inductance. So, but if I measure this one on the end here, nope, that one's still measuring zero. I thought this one was bad. This one not bad. Well, anyway, so this is the non-auto ranging LCR meter. I used it, but not as much. I normally used it for like testing components before I put them on a board, not in a troubleshooting aspect because of the lack of auto ranging and the lack of easily switching between things with a button. So I'm going to turn this off, move it to one side, and I'm going to break out the tweezers here. And I'll show you how they work. They should be set up for auto ranging. Yep. They're on auto ranging here. So let's zoom in so we can see what's going on. So we have our OLED display. Now let's measure that inductor again, and then we'll put it in auto and see what it gives us. So it gave us a series resistance of 153 megs. If I test it over here on this one, 715 megs. Make sure I'm getting it. And then now see I have K, 155K, and it jumped to megohms. But if I wanted to measure the inductance of that said filter, I could come over here to my inductance, which is L, and then I could measure this one right here, and getting 0 and 0 because that's what it's supposed to be. But if I come over and measure this one, I'm getting 150 nanohenries because that coil's bad. That filter I found out yesterday is bad. So, quickly I can test all my coils. Normally I do this with the microscope, but I can quickly test my coils to see if they're bad, and that one is bad. Unfortunately, I didn't test it with this. I was checking the pinout, the diode mode readings of this chip, and I came across an open line, and I couldn't figure out why, and it was because of that bad filter. So, but let's take example capacitors. Like this capacitor right here is on a low power line. This one in the middle of these two inductors is on a very low power line. And it seems to read a short, but if I take the series resistance of it, it will show me that it is not short. It'll show me 223 megohms. So that capacitor is open line. Is open. So that is definitely not a shorted capacitor. So if it's reading a short, the short would be somewhere else on the line and not that capacitor. So if you come across a capacitor that reads short and you're not sure if it's the capacitor or not, you can come up here and boom, that capacitor, between just the capacitor it has 600 megohms. So there is some instances where you get slightly weirder readings if there's a lot of parallel and series capacitors and whatnot. I'm not quite sure what's going on with this circuit over here, but if I measure this one, no, I got the megohms. Okay, anyways, there was an issue with this the other day. So, but apparently I fixed that when I put a new capacitor on. So, but, it tells you if, this is, that's an open capacitor because of the amount of resistance. Now, if you go to capacitor mode, now this isn't going to be exact because there's going to be capacitors in series or parallel. And then you can measure the capacitance here. That's 52 microfarad, but as it charges, it goes up, and then in the corner, it tells you it has a equivalent series resistance of 1.8 ohms. So there could be a lot of stuff in there, and I have it on auto ranging for whether it's in series or parallel. If you go to auto and you're not sure what something is, like this chip right here, what is this? This is giving me a resistance of 46 megohms, but I think it's an inductor. So let me switch to an inductor, which is L. And it's 1 nanohenry, or 554 nanohenry on that one. That one's roughly a little bit higher. So you can check the inductance, and then you can change the frequency of the reading. So this is at right now it's on auto frequency. So here's manual frequency. This is 100 hertz. So if you wanted to test the let's put it in auto on 100 hertz and check this cap right here. So there we go, 58 microfarad, and now we have a series resistance of 12 ohms. So, and we'll check this one again over here. So 6 microfarad, I know for a fact that that's a 1 microfarad capacitor. So there must be some in series to boost it up. So you can't use it to get an exact rating on it, but like I use it to see if I have a reading across the capacitor that reads short. So this is showing me it's a capacitor, 7 microfarad, and then I can check the resistance of that. And see if it, see I'm getting 100 kilo ohms, well 17 ohms now. That's 100 hertz. Okay, let me see, 1, 2 kilohertz, 10 kilohertz. So I can go to 10 kilohertz, let's do that. So let's check the resistance in 10 kilohertz. So now we're back in megohms at that high frequency. A lot of these capacitors are bypass or low pass filters, so they filter out certain frequencies. So that's why it's nice to have the different adjustments of the test. So let's just check a capacitor in 10 kilohertz and see what we get. See, now we have 7 microfarad at the 10 kilohertz frequency. So, and then I believe, and that was testing, I think that was testing in series or parallel. Yeah, that was testing at series. Now I can set it to 3. Now we're just doing parallel. I'm getting 0 megohms as a parallel. Resistance. There, now I'm getting the resistance back in parallel mode. So I don't use these for every little thing that they do, but they do work for what I need them to work with. These are quite expensive, you know, and make sure you discharge capacitors before testing. I don't use it on a live board ever. I'm not even sure if you can use it on a live board. I would not. So that is the LCR tweezers. These are the LCR meter elite tweezers. So, but you know, when I got to doing these little circuit boards and all the little stuff, this meter was just too much of a pain to swap between all the different ranges, and a lot of times I was getting readings I didn't understand. So I, you know, got those. I've had those for a while for doing other tests on my surface mount stuff on other projects I'm working on. So they work good for different projects. You spill a bunch of components on the table and you can easily measure all of them and then organize them and keep them straight and whatnot. So this is just a brief look. I'm not an expert on using these LCR meters. I just wanted to show that what I use them for, and that they're pretty neat. But that's going to do it for this video. Here is my links to social media and Patreon if you so choose. Thank you so much, and have